Imagine stumbling upon a hidden shadow lurking in the vast expanse of the cosmos. That's exactly what astronomers have just uncovered in a groundbreaking discovery. Picture this, a mysterious, ultra-dense clump of invisible matter, nestled within a galaxy whose light has travelled an incredible 7.3 billion years to reach our eyes. It's a find that challenges our understanding of the universe and leaves us questioning the very fabric of reality. But here's where it gets controversial. What if this isn't just some cosmic oddity, but a clue that could upend our theories about dark matter? In a remarkable display of cosmic detective work, using gravity as their primary tool, scientists have pinpointed this enigmatic blob. And it's not just any blob. At a mass roughly equivalent to 1 million suns, it's incredibly small for something spotted at such unfathomable distances. In fact, it's the tiniest object ever identified through gravitational effects from such vast reaches, beating previous records by about 100 times. To put that in perspective for beginners, think of it like finding a tiny pebble causing ripples in an ocean-sized pond from miles away. A feat of observation that's pushing the boundaries of our technology. This represents the lowest mass object we've ever detected at a cosmological distance using its gravitational influence by a factor of 2 orders of magnitude, explains astrophysicist Devon Powell, leading the research team at Germany's Max Planck Institute for Astrophysics. Their study, published in Nature Astronomy, highlights how gravitational imaging could open doors to exploring even smaller masses in the far-off universe. For those new to this, gravitational imaging is like using nature's own magnifying glass to peer into the depths of space. Speaking of which, this discovery ties directly into one of the universe's biggest mysteries, dark matter. Based on everything we observe about the cosmos, there's this elusive substance that doesn't emit any light and interacts with the rest of the universe solely through gravity. It's like an invisible force shaping galaxies and stars. Yet we can't see it directly. Scientists have various ideas about what dark matter might be, and understanding whether it's evenly spread out or clumped together helps narrow down those theories. But since it emits no light, mapping it is notoriously tricky until gravity lends a hand. And this is the part most people miss. Gravity isn't just a force, it's a cosmic sculptor. Every object with mass bends the fabric of space-time around it, much like how a heavy bowling ball creates a dip in a trampoline. Roll a marble across that trampoline and it'll curve around the ball's indentation. Now scale this up. Imagine the bowling ball is a nearby galaxy and the marble is a photon, a particle of light, from a distant galaxy. As those photons journey through the warped space-time, they get stretched, distorted, and amplified, creating what's known as a gravitational lens. It's a natural telescope that lets us magnify faraway parts of the universe in ways our instruments alone couldn't. These gravitational lenses are invaluable for studying distant cosmic phenomena. They act like nature's zoom lens, revealing details we might otherwise miss. But astronomers can flip the script, using the distortions in the lensed light to map out the matter distribution in the foreground lens galaxy. That's precisely what Powell and his team accomplished. They harnessed a powerful array of telescopes, including the Green Bank Telescope, the Very Long Baseline Array, and the European Very Long Baseline Interferometric Network, to focus on a famous gravitational lens setup known as JVAS B1938 plus 666. This setup features a closer galaxy, about 7.3 billion light-years from us, acting as the lens for an even more remote galaxy, roughly 10.5 billion light-years away. The light from that distant galaxy gets stretched and quadrupled in brightness as it passes through the foreground galaxy's gravitational field. One striking feature is a bright, elongated arc of light from the lensed galaxy. And within that arc, the researchers spotted a subtle pinch, like a dimple in an otherwise smooth curve. This anomaly couldn't be explained by the main lens galaxy alone. Instead, it pointed to an additional small mass clump nearby, confirmed with an astonishing 26 sigma level of certainty. That's statistical gold standard, meaning the chances of this being a fluke are astronomically low. From our very first high-resolution image, we noticed a narrowing in the gravitational arc, which was our clear signal that something intriguing was happening, says astronomer John McKean from the University of Groningen in the Netherlands. The only way this could occur is if there's another compact mass between us and the distant radio galaxy. Intriguingly, this mass doesn't shine in any detectable wavelengths. Not optical, radio, or infrared. It's either entirely dark or too faint for our current tools to pick up. So, what could this mysterious blob actually be? The top contenders are a concentrated lump of dark matter, or perhaps a dwarf galaxy that's too dim to spot with light. Both possibilities are on the table right now, and more studies are essential to crack this puzzle. Powell notes that their data's sensitivity made discovering at least one such dark object likely, aligning with the cold dark matter model that underpins much of how we think galaxies and cosmic structures form. Now that we've found one, the next challenge is to locate more and check if their abundance matches our theoretical predictions, he adds. This revelation is detailed in companion papers in Nature Astronomy and the monthly notices of the Royal Astronomical Society, sparking excitement and debate in the scientific community. But here's the controversial twist. If this blob turns out to be a clump of dark matter, it could reinforce existing theories. But if it's something else entirely, like an ultra-faint galaxy, it might hint at flaws in our models of the universe's composition. Some theorists even speculate it could be evidence of exotic particles or even micro-black holes, reigniting old debates about the nature of gravity itself. What do you think this enigmatic blob really represents? Could it be the key to unlocking the secrets of dark matter? Or does it suggest we need to rethink our entire cosmic blueprint? Does this discovery excite you? Or does it raise more questions than answers? Share your opinions in the comments below. Let's discuss and debate.